Hello everyone. In this video, we are going to learn the test of convergence for infinite series. In particular, we will be discussing about the ratio test. Okay. Now, let's let the series n from 1 to infinity an. It is a given to you, which is a series of non-zero terms. Then, suppose limit n goes to infinity, an over n plus 1 comes out to be a finite value, say rho. Okay, it comes out to be a value. Finite or infinite, we will see. Okay, now the series converges if this value is less than 1. The series diverges if the value is greater than 1. Okay, so as the name says ratio test, what we are doing, we are finding the ratio of an over an plus 1. So the steps that include in solving any question is we have to first find find an plus 1, and then find the ratio an plus 1 over an, and then take its limit as n approaches to infinity. And based on that, you will check the series converges or diverges. Okay, let's see with the help of example. Now this is your series. So in this series now, this entire term is your an. So let's write an is n factorial over 2 power n. Since we have to find the ratio, let's find an plus 1. So what you have to do, in place of an, you are writing an plus 1. So it means on the right side, wherever you see n, you have to replace by n plus 1. So basically this n and this n. Other things you keep same. So you will get, when you are replacing this n by n plus 1, so you'll get n plus 1. The factorial sign remains same over 2 remains same, just the power. It becomes n plus 1. Okay, so be careful when you are solving it. When you are finding the value of n plus 1. What I did, I replaced this n by n plus 1 and even this n in the denominator by n plus 1. Now, I hope you are familiar with the factorial notation. What it means, keep on multiplying by like decrease n by 1. Keep on multiplying until you reach 1. So for instance, if it is 3 factorial, it will be 3 times 2 times 1, which is 6. Similarly, if you want 4 factorial, this will be 4 times 3 times 2 times 1, that is 24, and so on. Now, when you have n plus 1 factorial, you need to write n plus 1 factorial as, see how you can write n plus 1, n, n minus 1, and so on to 1. So if you look at this term, what is it? To understand this, let's see. We have seen the example of 3 factorial, 3, 2, 1. Okay, 4 factorial, 4 multiply 3, 2, 1. So if you see, these terms are same. So how I can write 4 factorial? I can write it as 4 times 3 factorial. That's also going to give me the same result. So in the same way, we can write n plus 1 factorial as n plus 1 times n factorial. This is an essential step to simplify the ratio. Okay, so let's find the ratio. So let me write this thing here. N plus 1 factorial is n plus 1 times n factorial over 2 power n plus 1. Okay. So ratio we have to find an plus 1 over an. See, it's important to follow this like an plus 1 over an, because if you reverse this, the value of rho get reversed and the result will change. Okay. So always an plus 1 over an. So an plus 1 is n plus 1 times n factorial over 2 power n plus 1. Now divided by an, which is n factorial over 2 power n. Now using the law of exponents, you can split this into two terms, 2 power n into 2. Okay. Now simplifying it, this gives you n plus 1 over n factorial divided by 2 power n times 2. Now we are changing this division to multiplication, the basics of maths. Okay. And flip this number. This is just for simplification. 2 power n over n factorial. Now cancel the terms that you can cancel. You can cancel n factorial with n factorial, 2 power n with 2 power n. So this gives us, guess what we get? We get the ratio an plus 1 over an as n plus 2 over 2. Okay. Now what we have to do in the ratio test, we have to find the limit. So let's find limit. Limit as n approaches to infinity, an plus 1 over an, which is same as limit n approaches to infinity, n plus 2 over 2. So what this gives you? As n is in the numerator, denominator is just a number. So this value approaches to infinity. So you can say that the series diverges. Why it diverges? Because it approaches to infinity. And infinity is greater than 1. Okay, so diverges. But it's clear itself. Going to infinity, so it is divergent. Let's do the second question. Again, an is 2n plus 3 over n factorial. Finding an plus 1. What we have to do? Simply replace this n and n by n plus 1. Gives us 2 n plus 1 plus 3 over n plus 1 factorial. Let's simplify this before finding the ratio. So distribute 2 at both the places and writing the n plus 1 factorial as n plus 1 times n factorial. So you have 2n plus this will become 2 plus 3. This gives you 5 n plus 1 times n factorial. Okay, let's find the ratio. En plus 1 over en. This gives you 2n plus 5 over n plus 1 times n factorial divided by what you have 2n plus 3 over n factorial. Simplifying this gives you 2n plus 5 over n plus 1 times n factorial multiply n factorial over 2n plus 3. Cancel what you can cancel. You can cancel only the n factorial. So what you see here, the ratio an plus 1 over an. It turns out to be 2n plus 5 over n plus 1, 2n plus 3. Okay. Now, next is to find the limit. So if you look like limit n goes to infinity, an plus 1 over an. Limit n goes to infinity to n plus 5 over n plus 1 to n plus 3. So if you check here, the highest power of n in the numerator is n, and here it's n squared. So divide both by n power 2. So what you will get? This will give you limit n goes to infinity. Dividing by n power 2, it's same like taking n power 2 common from both numerator and denominator and cancelling it. So you will get 2 over n plus 5 over n squared divided by 1 over n, 1 over n squared. Okay, then 2 over n plus 3 over n squared. Fine. Now, as n goes to infinity, If n approaches to infinity, 1 over n approaches to 0, so is 1 over n square. So what you get when you substitute the limit? You get 0 plus 0, and in the denominator also, all the terms become 0. So this limit is 0, which is less than 1. So you say that by ratio test, the given series to n plus 3 over n factorial, n from 1 to infinity, converges. Okay, let's take another example quickly. This all is your an. Let's find an plus 1. This will be minus 1 to the power n plus 2. I'm writing now directly because I'm sure you are now expert of it. N plus 1, n plus 2. So what I did, I just changed the value of n by n plus 1. So an plus 1 divide an gives you minus 1 to the power n plus 2, n plus 3, n plus 1, n plus 2. Divide. So now I'm writing here again the direct step. So it is n plus 1, because what happened? This will get flipped. Okay. Minus 1 to the power n plus 1, n plus 2. But you can cancel. You can cancel this n plus 1 with n plus 1. Anything else as of now? Yes, minus 1 to the power n with minus 1 to the power n. So you left with minus 1 power 2, n plus 3. In the denominator, minus 1, n plus 2 to the power 2. So what this gives you? This will give you minus of n plus 3 over n square. Let's open the bracket. 4n plus 4. Okay. Again, the highest power of n is n square. So divide by n power 2. This gives you, yes, because we have to find the limit. We have to find limit n approaches to infinity of this. So we have to do this thing for finding the limit. So minus 1 over n, 3 over n square, all over 1 plus 4 over n plus 4 over n square. Okay. Now, as n approaches to 0, what happens? This term becomes 0, this becomes 0, even this and this becomes 0. So this gives you minus of, this is 0 plus 0. Here it is 1 plus 0 plus 0. So again it's 0 less than 1. So this implies it converges. Okay. Let's take another example. The last one. An is 6 over n plus 1 to the power n. Right? I can combine. Or if you don't want, let's keep it in the same form. So this gives you an plus 1. This is your an plus 1 as just changing the n to n plus 1. So an plus 1 over an. What you will get? You find an plus 1 over an. You will get, 6 power n. I'm splitting the terms here. Okay. N plus 2 to the power n. N plus 2. Okay. And here you will have n plus 1 to the power n over 6 power n. But you can cancel. You can cancel 6 power n. Then simplifying this gives you 6 over n plus 2. Then you can see that n plus 1 and this n plus 2, these are the terms with power n. So you can combine them together and write n plus 1 over n plus 2 to the power n. Okay. Now when it comes to finding the limit, n approaches to infinity, an plus 1 over an. This gives you limit n approaches to infinity 6 over n plus 2, n plus 1 over n plus 2 to the power n. So you can rewrite it as limit n goes to infinity, because this term, you know that this term, the first term, as n approaches to infinity, this approaches to 0, but you are not sure about this. Okay, so for this you have to convert it as like, you have to divide both by n. So you have to write it in the form 1 over 1 plus n, 1 plus 2 over n, this whole to the power n. Okay, because there the highest power is n, so you divide both terms by n. To evaluate this limit, you need to use this result. So what this result says that limit n goes to infinity 1 plus k over n. K can be any number. This whole power n is always e power k. So in this case, your k is 1 and here k is 2. So this gives you the limit as, see, I'm writing it as limit n goes to infinity 6 over n plus 2 times limit n goes to infinity of 1 plus 1 over n to the power n and 1 plus 2 over n to the power n. Okay, we know that this limit is 0. So, but we need to check if this limit is finite or not. Okay, because if this turns out to be infinite, then we cannot use the limit in the direct form. We have to use another rule. So, for the numerator, it turns out to be e power 1 and here e power 2. So, it is 0 multiply 1 over e. So, yes, since 0 multiply a finite number, we say it is 0. So, this limit is less than 1. So, this means that the series converges. I hope it is clear now.